Hey guys, welcome to 75-day LeetCode coding challenge, and today we are going to solve our next problem statement, maximum level sum of a binary tree. So let's start. Given the root of a binary tree, the level of its root is 1, the level of its children is 2, and so on. Return the smallest level x such that the sum of all the values of node at level x is maximum. So we have given a binary tree. We need to find the level which have the maximum node sum. So for this binary tree, if we start from level 1, there is only one node 1 and the total sum at level 1 is 1. Similarly for level 2, the total sum is 7 plus 0, 7. For level 3, the total sum is 7 plus minus 8 is equal to minus 1. So level 2 have the highest sum and our answer is also 2. So I hope you got the problem statement. Now let's discuss the solution part. So we have given a binary tree and we can solve this problem statement using BFS approach. So in BFS approach, we can use queue, and in a queue, we can store all the node of one level at a time. So if we start from the level 1, we can store all the node of level 1. So there is only one node, so we store it in the queue. Then we process the queue and find the total sum. So the total sum at a moment for in the queue is 10. For level 2, there are two nodes 5 and 6. We push it to the queue and take the total sum. So 5 plus 6, 11, and we have the level also. For level 3, there are 4 nodes. We push it to the queue and take the total sum. So 1 plus 2 plus 3 plus 4, the total sum is 10. So, and we are processing the sum level by level, and for each level, we are pushing all the node in the queue, right? So if we know the sum for each level, we can easily find the maximum sum, right? And also if we are keeping track of the level, at whatever level we have the maximum sum, we can easily return it. So this problem statement we can solve using BFS approach, and in the queue we will keep managing the total sum for that level, and once we find the maximum sum, we can return that level. So let's do the coding part to solve this problem statement. So first we are going to create our queue of type tree node type. We need to keep track of the maximum sum. So initialize it with the minimal value. We offer a root node in the queue. Iterate over your queue while it is not empty. To keep track of to keep pushing the all the node for one level at a time, we can use one temp queue also. So if we are processing the current level, we can use a temp queue and push the next level node in that temp queue, and at the end we can assign that temp queue to our current queue. So let's create a temp queue. Do while loop. So again we are processing our current queue. We are expecting that in our queue we have all the element of the particular level. Yeah, right, processing one level at a time. We can find a total level sum. So for level 1 the total sum is 10, for level 2 it is 11, for level 3 it is 10. Let's keep, we are processing one level at a time. Pop the node from the queue. We have a time queue, so we also need to push the next level node in our time queue. So if our left subchild is not equal to none, left node exists, push it to our time queue, node dot left. If our right node exists, push it to the our time queue. And when we are done with processing one level, we have pushed the next level node in our time queue. Now we can assign our time queue to our original queue. We need to keep track maximum sum across all the level. I think this name is misleading. So let's say current level sum. This will be more easy to understand. Current level sum. If our current level sum goes greater than our maximum value, it means we found a level where we are getting a sum greater than our maximum value, our previous level. So we can say initialize again with our maximum value with the current level sum. Right? So now we need to do one more thing. We need to keep track of the level, and then we need to find the level which have the maximum sum. So in this if block, we know that this level has the maximum sum, and we can we can define two variables. First, to keep track of the current level, and then we need to find the level that have the maximum sum. For we are processing one level at a time. So let's say we increment our level every time, and then if we know that our current level sum is going greater than our maximum sum, we can assign our the current level to our answer level. So now we know at which level we have the maximum sum, and at that level we assign the answer to our answer level. Now return your answer level. So we are done with the coding part. Now let's run the test case. So our test case is working. Now let's submit the solution. Our solution is also working. And thanks for joining the session. Let's meet tomorrow.